Whenever we do reactions in the lab, we measure our quantities of reactants first so that we get a certain quantity of product. That's how we plan our reactions. We don't just arbitrarily walk in the lab, take any amount of reactants and mix them up or start the reaction that way. We want to control our reaction and control the quantity of product we get. But even when we do all that and we expect to get a certain quantity of the product, let's say 20 grams of some product, in reality, things don't work out exactly as we plan. Instead of getting 20 grams, we may end up getting 15 grams. Why? Well, there could be instrumental error. What instrument you are using to measure the mass of your starting reactants, maybe it is not calibrated properly. Or it could be some human error. Perhaps you spill some of the product somewhere, or you measure incorrectly again, even if the instrument is working fine. In either case, the quantity that you actually are able to produce in the lab, the 15 gram, is called the actual yield. It's the amount produced when the reaction is performed in the lab. Theoretical yield is the maximum amount of product that can be produced, which in our case, in the example, would be 20 grams. The theoretical yield is calculated on a paper with pencil, just like in the previous examples we saw. The actual yield is practically obtained in the lab. There could be many other factors that could be present why the actual yield may be less than the theoretical yield. Doesn't just necessarily have to do with human error or machine error. It could even be other side reactions that happen that may consume some of your reactants. Sometimes the actual yield is more than theoretical yield. Usually that happens when there is some impurity in your product, such as the product has to be weighed when it's dry, but it's not dry enough, contains water, then it's going to weigh more, and it might have more mass than the theoretical yield allows. In either case, we can test for the exact percent of our product by through something called percent yield. We can find out how good our experiment went by finding the percent yield of the reaction. Percent yield is calculated by dividing the actual yield by the theoretical yield and multiplying it by 100. For example, if a reaction's theoretical yield was 132 grams, while the actual yield was 125 grams, 125 gram divided by 132 times 100 tells you that you had a percent yield of 94.7%. Could this percent yield be improved? Perhaps it could be improved. Sometimes there is an upper limit to the percent yield in real life, and sometimes finding just another way of doing the experiment that gives you a better percent yield makes all the difference in an industrial environment where there is competition in how companies are able to produce their products and bring it to consumers. Let's look at an example of percent yield calculation. So here is a reaction of aluminum reacting with iron oxide rust to produce aluminum oxide and iron. Now if the theoretical yield of iron was 30.0 grams, so here is iron. This reaction is generally carried out to produce iron. If the iron amount that theoretically we could produce was 30.0 grams, and how exactly are we getting this number 30.0 grams? Well, maybe we started with certain moles of aluminum and certain moles of iron oxide that would give us 30.0 grams of iron. And the actual yield turned out to be 25.0 grams. Calculate the percent yield. So 25.0 gram divided by 30.0 gram times 100 gives you a percent yield of 83.3%. Calculate the percent yield if 26.8 gram of iron was collected in the same reaction. Perhaps somebody else did it and they were able to produce more iron. Then what's the answer? 26.8 gram divided by 30.0 times 100, whatever percentage you get there would be your percent yield in that case.